Well, hello and welcome to today's video. Today we're going to be talking about how to solve quadratics using the quadratic formula on there. So let's go ahead and get started. Your learning intentions for today is that you will be able to solve quadratic equations using the quadratic formula. And there's going to be several steps along the way that I'm going to show you there. But the first thing that you're going to need to be able to do is to identify the A, B, and C values of a quadratic equation. If you can't do that, it's going to be very hard to get past the rest of this. The other is to be able to find what's called the discriminant. Now, what the discriminant is simply just part of the quadratic formula that's going to tell you how many solutions you're going to have. And it's whether you're going to have one answer, two answers that are real, in other words, I can graph them on the number line, or two imaginary, in which we know that means that it's not going to cross. So the next thing is that you're going to be able to identify when you need to use the quadratic formula and when you don't. And then also you need to be sure that you have that quadratic formula memorized. That's going to be a key to what we're going to be doing. So the vocabulary words we're going to be talking about is what's standard form, what is the discriminant, then what are real solutions and imaginary solutions, how do I know the difference between the two, and what is the quadratic formula. Now this is going to be a two-part video. The first part we're going to talk about the discriminant, and then the second part we're actually going to run through some quadratic formulas for you. So let's go ahead and get started on this one. So before we get too far down the road, the first thing you need to know is what is the standard form for a quadratic equation, okay? And the standard form of any quadratic equation is ax squared plus bx plus c. Now, sometimes you'll see that equal to 0. Sometimes you will see that, especially when you're wanting to graph, you're going to be seeing it equal to y, or you might see it equal to f of x, any of those. But for all of them, it's still going to be the same basic form. Okay, so just be sure that you know that. And so, of course, sometimes you see it without it equal to anything if it's just a factoring problem. Now, the key for this one is that your B and your C can equal 0. That's okay. We can have B and C equal 0. But what you cannot have is A can never be 0. If A is 0, then you're only going to have the BX plus C left, which makes it then a linear, not a quadratic, okay? So just realize your A can never be 0. Now, the quadratic formula comes from that, and if we have time, I'll actually have you figure out the quadratic formula on your own, but for right now, I'm just going to go ahead and give it to you. Now, we've had three methods to finding the solutions for a quadratic equation, and they were factoring, okay? That's when you always had two real solutions, okay, real solutions. You had completing the square, and now we've got the quadratic formula. Okay, so those are your methods that you're going to use. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, make the square root a little longer, all over 2a. Now, a couple of things that you need to be careful with and make sure that you do. One is that if b is equal to a negative number, then you must always put parentheses around your b. Okay, that's a given. If you don't put parentheses around it, you're going to get it messed up, especially if you are plugging things into your calculator. Okay. The next thing is to always remember that this is all over 2a, not just the radical piece of it, but all of it. Okay. The next thing is the discriminant. Well, what is the discriminant? Well, the discriminant is simply this piece that is underneath the radical. Okay, so it is the b squared minus 4ac. And if you think about with what we've done before, we've simplified radicals, if I have what's under the radical, let's say, is a positive number, Okay, so like the square root of 9. Okay, then I can do that. That's 3. Okay, now in terms of our quadratic formula, there's a plus or minus out in front of it, so it would be a plus or minus 3. If I had the square root of 0, then that's just 0. Okay, and if I have the square root of, let's say, a negative number, okay, like maybe a negative 9, then that's when I have my imaginary number, and it would be 3i. Okay, so that's what we're going to be talking about as we do this here, is what's under the radical. What kind of number is under the radical? That's going to tell me how many answers I have. So here's the rules. If what's under the radical, the discriminant, is greater than 0, in other words, this positive number, you're going to have what we say is 2 real solutions. What that really means is you're going to have 2 x-intercepts when you graph it. Okay. If I have b squared minus 4ac and it's equal to 0, I'm going to have 1 real solution, and that's where we call that a multiple root. Okay, and then if I have b squared minus 4ac being less than 0, then we have 0 real solutions, and that's where we get our 2 imaginary roots. Okay, and what that means in terms of our graphing is our graph is not going to cross the x-axis. Okay, so let's go ahead and find some discriminants. So here is our I do's. Okay, and it says to find the discriminant and determine if the solution has 1 real, 2 real, or 2 imaginary. So the first thing you need to do always when you're doing the discriminant or solving the quadratic formula, either one, is you need to have all of your a, b, and c all moved to one side. Okay, we've got to have them set equal to 0, set equal to y, set equal to f of x, doesn't matter, but they must all be on the same side. And that's the case of the first one here. So the next thing to do is always identify your a, b, and c. Okay. Now remember, your a is your coefficient of your x, in this case it's 1, or your x squared, sorry. Your b is your coefficient of your x, which is 4, and your c is your coefficient or your constant, if you would like to call it. Sometimes you could hear called it x of 0 on there, but your constant is probably the easiest thing to call it. Okay. Then to find your discriminant, I'm going to go ahead and write that down. Okay, and we're just going to put some numbers in. So b is 4, a is 1, and c is 3. And I'm just going to simplify doing a quick order of operations. So I do my powers first, and then I'm going to do my multiplication. 4 times 3 is 12. Okay, and so that gives me 4, which is a positive number. And so if you'll remember the rules, and if you want to, you can put them up above. So b squared minus 4ac is less than 0. Oops, sorry, my bad. Equal to 0. I'll look at which one it says. It's got 1 root. If b squared minus 4ac is greater than 0, it has 2. And b squared minus 4ac less than 0, then it has 2 imaginary. Okay, and so this one is going to have 2 real. That's all you got to do. Pretty easy. Okay. Number 2. If you want to pause it so you can try it on your own, I would suggest that you do that real quick. So a is going to be 1 again. B is a -2. And C is 1. Okay. Hopefully you have no trouble identifying those. So my discriminant again. And I'm going to plug my numbers in. So a -2, remember I told you anytime you plug in a negative, you got to put parentheses around it. The square must be on the outside. A is 1 and C is 1. So in this case, I have a -2 squared, which is 4, minus 4 times 1 times 1, which is 4. This is going to give me a 0. Okay? So if it's equal to 0, that means I just have 1 real root, and it's going to be a multiple. and I'm going to back up and just show you what I mean by that. If I took this and I factored it, and I said, what are the factors of 1 that give me 2, negative 2? Hopefully you know it's x minus 1 and x minus 1. See how that's the same one? This is x equals 1 and 1. I won't write it down twice. I just say that it's a multiple root. So it is x equals 1 is how I would write it. And then I would say with a multiplicity of 2. Okay, and you do have to state the multiplicity because later on, when we get into higher powers, then you could have higher multiplicities than 2. Okay, next one is, again, it's not equal to 0. It's not equal to y. It's not equal to f of x. So I'm going to move things around and get it all. So I'm going to move my 3x. And then I'm going to move my 2. Now it's equal to 0, and I'm going to identify my a, b, and c. So a is going to be 1, b equals a negative 1, and c equals 2. Okay, again, we're going to just plug it into our discriminant. I keep writing that over and over. I really suggest you do that. It's going to help you just to remember it. So b, again, it's negative, so I'm putting in parentheses, minus 4 times a times c. So a negative 1 squared is 1, and then minus, and 4 times 1 times 2 is 8. And guys, I have sometimes people who have trouble with this sign. I just kind of look at it from, basically from everything from here over, and I look and I say, okay, I only have 1 negative, so I know that's going to be negative. If I have 2 negatives, that's positive. If I have 3 negatives, then that's negative again. So hopefully that makes sense. So in this case, I'm going to get a negative 7, which goes over here, which means when I try to take the square root of a negative, I'm going to get 2 imaginaries. Okay. Let's try 2 more. Again, if you haven't paused it to try it on your own, I would definitely suggest that you do that. So minus 3x, 2x squared, minus 4x, plus 3 equals 7. Let's move the 7 over. Here we go. Okay. So I'm running out a little bit of room. I'm going to pull it over here to the side. So a in this case equals 2. B equals a negative 4. And c equals a negative 4. Okay. So again, my determinant. So b is a negative 4. A is 2. C is a negative 4. So 16. Again, what I was telling you earlier, when I look at this, I have 2 negatives. So that's going to be plus. And 4 times 2 is 8. 8 times 4 is 32. And that gives me 48. That is a positive number. So if you'll remember, if it is positive, okay, greater than 0, it has 2 real. Okay, and then the last one real quick. Again, if you haven't tried one, I would pause and do that. So I'm going to minus 3x squared. You could go either way with it. It doesn't make any sense, any difference. Some of you like it always being positive. And now I'm going to move my 5 over. So negative 4x squared equals, negative 4x squared minus 3 equals 0. Okay, so a in this case is negative 4. B is 0. See, there's no b there. And c is a negative 3. So again, let's go through. So b is 0. A is a negative 4. And c is a negative 3. Okay. Again, back with what I was telling you on there. Whoops. I have 3 negatives, so my answer is going to be negative. And 4 times 4 is 16 times 4 is 48, or 16 times 3, sorry. 4 times 4 is 16, times 3 is 48. So I'm going to get a negative 48. And if it is negative, then it is less than 0, which means I have 2 imaginary roots. Okay, so hopefully that makes sense. That's just finding the discriminant. And again, what that is that's simply just telling you how many x-intercepts you're going to have or how many roots you're going to have. So that's just a piece of the quadratic formula. The quadratic formula actually finds those values for you on there, and that will be our next video.